Hi, my name is Campbell, and I'm a part of the Renewable Energy Long Island National Solar Tour, which happens every first weekend in October. I open my house and I take people around and I show them some of the things they can do in their home. We went to Bill Chalif, a solar architect, with 7 challenges. We wanted it to be energy efficient, we wanted it to be environmentally friendly, we wanted sustainability, we wanted it to be a healthy home because you spend most of your time inside your house, and we wanted it to be small but spacious, leaving enough yard. We wanted to have mass appeal so that people would look by and not say, oh, that looks like a UFO. It might be great to have all those energy efficient things, but who the heck would want to live in it? And finally, we wanted it to be affordable. Nobody's going to want to build an energy efficient home that actually costs more to build. It doesn't make sense. When building an energy efficient home, you want it to be both environmentally friendly and you want it to be sustainable. Environmentally friendly means you don't want to disturb the natural environment too much when you build a home there. And to have it be sustainable, you don't want to deplete any resources that go into the home, and you don't want to create any toxins that then go back into the environment. So this house is energy efficient. What does that mean? It means we're going to use less energy, whether it's electricity, fossil fuels, or water. What is our total consumption? Our total consumption, cost of total consumption, is 1/3 of a comparable home, a 3-bedroom home. That's significant when you start thinking about the future and how the price of oil or gas is going up. And also the summers are hotter and the winters are cooler. Climate change is happening. So energy efficiency is very important. We wanted it to be affordable. This home was built for an average of about $135 per square foot. Some people wanted to build this home for us for $300 a square foot. Couldn't do that. But we were able to build it in the end for on the average of $135 per square foot. Affordability is very important when building something you're calling energy efficient. So come on in. One of the reasons we moved out here is we love trees. We wanted to live underneath big trees too. And there were many of those on the property. When we marked out the spot where the house was going to be, we realized that there was one large oak tree that was sitting right where the house was going to go, and that was this one right here. It was standing right here. When I talked to Bill Chalif, I asked him if we could work this into the design, put it at the foot of the stairs, and he said yes, he could. So we actually built a foundation support down here, 4 feet deep and about 4 feet wide, to hold this tree, the center column of the house. So everything inside the house is held up by this tree. So we have great respect for this tree. One of the things you want to do when you have build an alternative energy efficient home is you want to take your landscape into consideration. That means taking out deciduous trees on the north side and leaving coniferous trees there for windbreak, and on the south side nurturing the deciduous trees, but cutting that canopy as high as you can. That's going to create a cool environment in your backyard and shade, but in the winter, when all those leaves are gone, it'll allow that sunlight to come through your passive solar windows, heating your house. We knew that we were going to be faced with both, number one, heating the house and cooling the house, but also creating a fresh air exchange in the house so that we would constantly have a healthy flow of air coming through. So what that meant was creating an air handler way up top through the air handler that would bring in the air from above, treat it up there in the attic, and filter it, heat it, cool it. It would bring it down through this thermal mass wall, which is 13 feet wide and 22 feet tall, underneath this 2.5-inch slab of concrete, through multiple air ducts here and up through the registers, and have a constant flow of air that is fresh, filtered, and healthy for your home. Cool in the summer and hot in the winter. That was what was very important for us. It saves money and it also creates the healthy home that you want. Okay, these are our solar panels. We have a 1.8 kilowatt system. So these are 300 square feet of laminate solar coming down through standing seam metal. Each one plugs in almost like a Christmas tree light up at the top into a main cable that goes along the ridge of the roof and then plugs right into the attic into a DC connector that has a switch on it. So this is our inverter. What this does is it takes direct current straight from the solar panels, and this records how much electricity is coming off our solar panels. It will tell you exactly what it's creating right now, which is 1,319 watts. We've gained, since it was installed, over 13,000 kilowatts, and today it has given us 5.8 so far. Now, we're not using electricity right now in this house, not very much. So that will go through back to our meter, through the AC, back to LIPA, and turn our meter backwards so that we're selling back our electricity for the same thing that we're paying for it. So as you can see, we have net metering here, and right now it is working. This digital clock is working backwards. Whenever we see those multiple 8s there, those are zeros actually, it's working back. We're feeding electricity back to LIPA, dollar for dollar, same price they charge us, they're paying us. When electricity is going back to them, it turns your dial backwards. Whenever it says diagonal, that means we're feeding electricity back to LIPA.